I love volume by cross sections. Another one. R is this region up here. It's enclosed by the first quadrant and bounded by these two curves. I like to label the curves if you're able to. I know our test is going to hybrid, which means it's digital, almost all of it. So you might not be able to label it, but you could always draw a quick little image for yourself and label it yourself. Now, because we're trying to define the volume using cross sections, we need to know an area formula for our cross section, and these cross sections are squares. It says it somewhere. There it is. It says this is squares. So it's just side squared. All right. So next we have to note that the cross sections are perpendicular to the x-axis, which means they're like this. Okay, they're going from one curve to the other, perpendicular to our x-axis. Okay, so why is that important? That's important because that means we're going to need to write our area function in terms of x. Now, I tried to draw a three-dimensional square here sticking off the page. I know it bothers some of you guys. It's not that good. I know it's not that good. But you'll see that the side right here, the S, one of the sides, lies between these two curves. And so if you wanted to find the distance between these two curves, like if you wanted to find the length of this side, you're just going to have to subtract these two functions. And so that's how we get 2x minus x squared as one of our sides. And so instead of saying s squared, now I can say 2x minus x squared. And this right here represents the side. So now our area is written in terms of x. Now we can find the volume by integrating that foo. All right, let's integrate that foo. Who's that? Okay. So I plugged in the area into my integral. The next thing I need a lower and upper bound. It looks to me that this lower bound is clearly 0. This one, I'm not so trusting right here. I don't trust pictures in math. Is this actually 2? I don't know. There is luckily a way to figure this out. If there wasn't a way to figure this out, I would just have to trust it. So what you would do is you just take the two functions, you set them equal to each other because it's a quadratic, get everything on one side, factor it, then solve it. It looks like I get 0 and 2, so that is 2 is the point of intersection right there. The other one is at 0, which we already knew. Okay, so I'm going to put 2 up there, and now let's integrate. Now to integrate this one, you could... I don't know, U sub probably would be kind of messy and dirty. So I'm not going to use U sub. I'm going to instead do the squared. So I'm going to go 2x minus x squared twice and FOIL this foo. A little bit of simplification. And then I'm going to integrate this from 0 to 2. When I integrate the first term, I get 4 over 3 x to the third. And that's because we add 1 to the 2, and then you have to divide by that number that you get. I get 3, and then I have to divide by 3. Right here, I get 4, then I have to divide by 4. That's why there's no more number right here. And here I get 5, then I have to divide by 5. That's why I have a 1/5 right there. Now let's plug in the 2, and then subtract, plug in the 0. Luckily, everything is multiplied by the x, so that means we're going to get 0, which is a beautiful thing. So when I plug in 2, this is what I get, and then I plug in 0, that's what I get, just a lonely little 0. Everybody say, aw. And then, let's see, a little more simplification. You know, I wasn't really excited when I did this. I was like, oh my gosh, are you serious? I'm going to have to simplify this, and yeah. I mean, if this was an FRQ, you can just leave it, just like this. You just box it up, you're done. But because it's a multiple choice, oh my gosh, I got to find common denominators. This stinks. I know, I hate arithmetic. This is no fun. Okay. This one I actually had to multiply out because who can do that in their head? Maybe you can. I don't know. I can't. So I have my negative 240, and I'm going to add the two positives together. I get a positive 256 over 15. And when I add those dudes together, I get 16 over 15, which is our answer. Whew!